This is the circuit diagram for the analog oscillator. The first step in understanding this circuit is understanding how a transistor works. A transistor consists of three leads: the emitter lead, the base lead, and the collector lead. The way it works is that it has two negative slabs on the outside with one positive slab on the inside. When current is passed into the positive side or the base lead, it squeezes together and lets current pass through it. Think of a transistor like a button that uses current to push it instead of your finger. Now that we know how the transistor works, we can get on to how this circuit works. This circuit works in a way so that when the capacitors are charging, it creates pressure on the base lead of the transistor, allowing the other capacitor to discharge. When the capacitor finishes charging, the other capacitor will start charging again, creating pressure on the other base lead of the transistor, allowing the capacitor that has just charged to discharge, creating a cycle where the LEDs light and dim according to when the capacitors are charging. The first step in building this is a breadboard prototype. For this, all the parts on the following table will be used. By following the circuit diagram, you should get a working circuit that looks like this. Once you have built the prototype, the next step is to solder it onto a PCB. Using all the parts from the prototype and the parts from the table here, you can solder this circuit on the PCB. While soldering, keep in mind to solder with overhang. If you need extra help with this, look at the soldering with overhang video on the ACES website. Now that you have it soldered, the last step is to put it in a case. The first step is to attach the positive and negative leads of the power jacks together, providing another option for power. Finally, simply place the PCB in the case, and voila, you've got a working analog oscillator. Thank you very much for watching. I hope you learned something. Have a good day.